Okay, this video is meant for my geometry kids. We have a test on Monday or Tuesday covering Chapter 10. Here is some problems. So again, this is a test, not a quiz. Test review. Right, test review. Good, on Monday or Tuesday. So, I have 6 problems. Let's take a look. Find the measure of each arc in circle P. Right? And this is going to be a good review of arcs, the type of arcs, and how to find the measures, right? Remember that the central angle is equal to the measure of the minor arc, right? So those are the same. So in this picture here, let's go ahead and figure out the other 2 minor arcs here. We have a 128, we have a 90. TD is a diameter, which is something to note. TD is a diameter. So if TB, if this is 90 degrees, then so is BD. So is arc BD. So that's 90. And then CD here is going to be what's left over after we take 180 and subtract 128. That's 52. So CD here is 52 degrees. Good. And now I think I can find these 3 arcs. So the first one, TB. 2 letters. This is a minor arc. Its arc measure is 90 degrees, equal to this right angle. Second one, BC is another minor arc. 2 letters. B to C. Now this requires arc addition. 90 plus 52. That's 148. Oh, I'm sorry, 90 plus 50, sorry. 90 plus 52 is 142. Cool. And then the last one, BCD. Now BCD, this is a major arc. And then we follow around, BCD. So BCD requires arc addition of 90, 128, and 52. So that is 128 and 52, that's 180. 90 and 180 is 270. So you can also, remember, you can also think about, okay, well, BCD is everything but arc BD. So I could take 360 minus 90 and get the same thing of 270. Okay? So there's a brief review of major, minor. Remember, semicircle, 3 letters. So in this case, a semicircle would be arc TCD. Right? So arc TCD would be a semicircle. So this arc right here. TCD, semicircle. Okay? Alright, next. Okay. Good question here. We did this one in class. I just want to review it with you. A landscape architect is constructing a curved path through a rectangular yard. The curved path consists of 2 90-degree arcs. He plans to edge the 2 sides of the path with plastic edging. What is the total length of the edging? Length, right? Okay. So, you know, part of the problem with this test might be you have trouble understanding, you know, measure, arc length, area. You know, what are you supposed to do? So make sure you really think through the problem and see the key words. Well, this is an arc length problem, okay? Now, it says 2 90-degree arcs. Those 2 90-degree arcs are right here. Okay? So this picture is very symmetrical in that this right side is the same as this left side. So we're going to focus on this right side first, understanding that we need to find this length and that length. But these 2 lengths are the same as this length and that length. So when we focus on this top picture, right, we focus on this top picture here, we'll just double it and get the bottom picture. Okay. So what do we got here? Well, I have an arc. Actually, I have a section of a circle. You see this? If I were to continue to draw the circle, there it would be. Right? So this is a section of the circle. This is an arc length. Find this arc length. Let's call it lowercase l. L is equal to the measure of the arc out of 360 degrees times the circumference, because it's length, pi, times diameter. Because it's a 90-degree arc, that's its measure, times pi, and the diameter. Well, this 4 is the radius. So again, you could think if this is the circle, extend it up here. 4 and 4 make a diameter of 8. There you go. Times 8. And this comes out to be 90 divided by 360 times pi times 8, 6.3. And that would be in meters. So that's lowercase l. Okay. And now we're going to use the same angle, but now we're going to find the uppercase L, this arc length, using, and I'll do it in blue. How about I do it in blue? Using this section of the circle. And again, you could visualize that bigger circle being formed around. So now the radius is 4, and 2, the radius is 6. Okay? So, to find the arc length capital L, still to measure the arc over 360 times pi diameter. We're still doing 90-degree arcs. Our diameter is now going to be double 6, right? Because the radius is 6, so double 6 is 12. 90 divided by 360 times pi times 12. I got 9.4. Oh, and that's not, I'm sorry, this is not meters squared over here. We're doing length, it's just meters, right? Sorry about that. So now, to get the entire edging of both sides, we just add these two numbers and we double it. Okay? So the total is equal to 2 times 6.3 plus 9.4. 2 times 6.3 plus 9.4. I got 31.4. And that would be meters, because it is length, right? Not meters squared, but meters. Be careful of your units. Okay. Good. That's a really good question. I really like that question. That's such a nice real-life example of this stuff. 3 here. Again, another familiar problem, but just to make sure that you really focus on it. So here we go. We have a regular hexagonal nut here. Okay? And the question is, what is the area of the hexagonal face to the nearest, and this should actually say square millimeter. To the nearest square millimeter. Okay. So what does this mean? Well, it means this part doesn't matter. This 2 millimeters doesn't matter. That's the thickness. All I care about is the actual face of the nut, right? With this circle cut out of it. So I'm looking for this shaded region around the circle. So this problem is find the area of the hexagon, find the area of the circle, and subtract. So that's what I'm going to do. Okay? Alright, so let's go with the area of the hexagon first. Here it is. To find the area of this hexagon, we're going to draw the center, radii, apothem, side length. Now, in this picture, it's hard to see, they have it taken out for some reason, but this is 8, and that's 4. So the 8 millimeters is the radii of the hexagon, going from the center to one of the other vertices. So 8 and 8. And now I'm looking for the area of this regular polygon, 1/2 AP. That is going to be 1/2 the apothem, which I do not know, times the number of sides, which I do know is 6, times the side length, which I do not know. Okay. So now I focus on this triangle here, and I look for the central angle, and that central angle is 360 divided by 6, that is 60 degrees. And now I focus on one of these right triangles down here. Right angle, apothem. 8 is this hypotenuse, or the radius, and now take half of 60, which is 30, and half of s, which is 1/2 s. Okay. And now we're looking for this apothem. This is a 30, 60, 90 triangle. We're looking also for the side length. We can label this using our 3 labels, right? Now, since s is here, I'm not going to use s, I'll use x. So, across from 30 degrees is your x, that's the short leg. Across the right angle is your 2x, that's the hypotenuse. And across from the 60 degrees is your x square root of 3. Now, I need to find x and x radical 3, so I know what 2x is. 2x is 8. Divided by 2, x is 4. That means half of my side length is 4, times 2. Your side length in this problem is 8. And there we go. There's my side length. And now my apothem is equal to x radical 3. X was 4. 4 radical 3. And there is my apothem. And how about that? I just multiply it all out. Be careful of the radical because a parenthesis opens. 0.5 times 4 square root of 3 times 6 times 8. I got 166.3. And that would be millimeters squared. And that's the area of the hexagonal face. Okay. And now the area of the circle. The circle's here. Just has a simple radius of 4 millimeters. Radius equals 4 millimeters. So the area of the circle is pi r squared. Pi times 4 squared. That's 16 pi, which is 50.3. And now to find the area of just the shaded region of just the nut's face itself, we're going to take the 2 and subtract. So the area is 166.3 minus 50.3. That gives me a 116.0. So just do 116 millimeters squared. Again, such a good problem, such a great modeling question, right? Of using geometry to model the situation. Good stuff. Okay, halfway there. Here we go. Find the area of the shaded segment to the nearest tenth. Okay, so this is a 3-step problem, right? First step, find the area of the sector. The sector is this guy right here. So I'm going to find the area of that sector. So area of the sector is equal to the measure of the arc out of 360 times the area of the circle. So, do I know the measure of the arc? Yes, I do. Or I can find it, right? This is 300. So to find this angle or this arc, it's everything but the 300. 360 minus 300. That's 60. That angle is 60 degrees. Which means that arc is 60 degrees. So that's what we use at the top number. 60 over 360 times pi, and then your radius is given to you 7 squared. So this area comes out to be 60 divided by 360 times pi times 7 squared. 25.7. And that would be meters squared. And now we find the area of the triangle, and this is the tougher part, right? So here we go. Area of the triangle is just 1/2 base times height. I'm going to take this triangle, draw it right here. Again, I just do my best to try to keep it the same orientation. So this is 7, this is also 7. That angle right there is 60 degrees. And now I draw on the height, which is perpendicular. So this is the base and this is the height. And now I'm going to focus on just half of the triangle. So let's focus on this upper half. How about that? So there's the right angle. Here's my 7. Now, this is my height. So it cut the base in half to be 1/2 the base. And it cut that angle in half to be 30. And here's your 30, 60, 90 triangle. Okay? Label the sides. Opposite of the 30 degrees is your S. Opposite of the right angle is your 2S. Opposite of 60 degrees is S radical 3. Alright? I know what 2S is. 2S is 7. So divide by 2. S is 3.5. And now I know what the base and the height are now. I can find the base. Half of the base is 3.5 times 2 times 2. The base is 7. So in this formula, and I'll skip it over here, 1/2. The base is 7. And now to find the height, well, the height is just S square root of 3. The height is S, which is 3.5 square root of 3. I'll just put that right here. And I'll multiply that out. Again, being careful of the square root with the parentheses. 0.5 times, times 7 times 3.5 square root of 3. And I got 21.2. and that would be meters squared. So now, to find the area of the segment, last part, and I'll do it right here, you just take the two numbers, 25.7, and subtract 21.2. 25.7 minus 21.2 is 4.5, and that would be meters squared. And again, this makes sense, right? Because that sliver, that segment, is just a small piece of that sector. So notice there's only a small piece of the area left over. Okay? So again, these are not easy problems. Practice, practice, practice. If you get these problems right, you're sure to get a good grade. So practice. All right, two more. Here we go, transportation. At a given bus stop, a city bus stops every 16 minutes. If a student arrives at his bus stop at a random time, what is the probability that he will not have to wait more than 4 minutes for the bus? Okay, let's use a number line, right? Or use a segment, right? This is a segment problem. So here's my segment. The bus comes every 16 minutes, so 0 to 16. So a bus comes at 16. Now, I want to see what the probability is that I do not have to wait more than 4 minutes. Okay? So let's break up this time interval into 4s, right? 4, 8, 12. That'll give me. So I need 3 markings. 4, 8, 12. 4, 8, 12. So if a bus comes here at 16, if I want to find the probability of not having to wait more than 4 minutes. No more than 4 minutes. So that means 4 minutes or less, right? I need to know the part of the segment that represents that 4 minutes or less. Well, that is this right here, between 12 and 16. That's your favorable outcome. That's the time that is 4 or less to when the bus comes. Notice how many parts of that whole segment does. That's just one part out of the total number of lengths in the segment. 1, 2, 3, 4. And there you go. That could be your answer. Or if you divide them, that could be your answer. Or if you times that by 100, 25% could be your answer. So any 3 of those. Again, pay attention to the directions. They might tell you. If they don't, just ask me a question. But there's using a segment to represent a probability question. Alright, and then the last one, again, another one of my favorites, these target questions. Here we go. So we have a target here. And again, I'll do my best to draw on the target. The target has a diameter of 14 centimeters. So we're going to ignore the box. It's just the circle. So that's the diameter. Diameter equals. So remember now the radius is 7 centimeters. That might be helpful later. The diameter of the center circle is 2. So I'll do it right here. So the diameter of that center circle is 2. So that means the radius is 1. Keep that in mind. And then it says the width of each ring is 2 centimeters. So if I keep going out, right, 2 centimeters, 2 centimeters, 2 centimeters. Each of those is 2. Okay. And now the question is, find the probability that it hits either the blue or the red region. Okay? So if I'm looking for the probability that it hits blue or red, I want the area of the blue or the red over the total area. Okay? So to do this, first let's find the total area. And I'll do that. I'll do it. It's fine. Area total. Do it in green here. It is a circle. Pi r squared. Pi, I wrote it down here. The radius of the entire thing is 7. That's 49 pi. 49 pi is 153.9. And that's centimeters squared. That's the total. That's my bottom number. Now, the top part is just a little tricky because you want to find the area of just the blue and the red. Well, you have to work with circles, and if I find the area out to the blue, that circle would include the white, red, and blue. So that's the first thing I'll find. I'll find the area of the blue, the red, and the white. Okay? The blue, the red, and the white. So that's a circle, pi r squared, pi times the radius of that. Well, let's see. Okay? that would include the 1 for the white, the 2 for the red, and the 2 for the blue. That's a radius of 5. So that's 25 pi. That is 78.5. And that's centimeters squared. And that includes the red, white, and blue. Okay? But I don't want the red, the white, and the blue. I just want the blue and the red. So I need to get rid of this white. So find the area of the white alone. Again, it's another circle. Its radius is 1, as we talked about before. So that's just 1 pi. And 1 pi is 3.14. And that's centimeters squared. So to find the area of just the blue and the red that I need on top, we're going to subtract. So we're going to take 78.5 and subtract 3.14. 78.5 minus 3.14 gives me about 75.4. And there's my top number. And I will divide these two. 75.4 divided by 153.9. And I get something like 0.4899 times that by 100. It's like 48.99, which rounds up to 49%. Okay. So there you go. So again, these target questions, these target ones are very key. Make sure you can do them. Okay? So these were 6 really good questions. I mean, some of these questions are tough, so make sure you do a good job of practicing, and we will see you on Monday or Tuesday. Thanks for watching.